Hello, hello. This is a follow-up video on conditional probabilities, but this time we're going to use something a little bit more visual with a standard deck of cards. So here we have a standard deck of 52 cards. We have clubs that look like clovers. We have spades, hearts, and diamonds. There are black cards, there are red cards, and there are face cards, which are the Jack, Queen, King. So just a little overall probability, right? There are 52 cards. So if we're looking for a face card out of the deck, it's going to be out of 52 because that's kind of the pool that we're pulling from. Now there are a total of 12 different face cards. So the odds of randomly pulling out a face card from a deck of cards is 12 out of 52. We have the pool that we're choosing from on the denominator and the options available in that pool on the top. That's going to be really important to remember as we go forward. All right, so we're going to start with a real quick review of the formula for conditional probability. We read it that the probability of B given, this line is given A, is equivalent to the probability of A and B happening at the same time divided by the probability of A. So the first conditional probability that we're going to have is that we're given that a red card is chosen. So what we do is we shrink down the denominator, we limit the pool, and we pull out just the red cards. So we have ace through king of hearts and diamonds. Next, we're going to practice computing some of these probabilities. So first, our overall, we have 26 cards here, right? 26 cards are red. So let's see how many of these are face cards. Of the red, there are 6 face cards out of 26, and that means 3 out of 13. Now, how many aces do we have? This would be the probability of an ace given that it's a red card. We have 2 possible aces, so it's going to be 2 out of 26 or 1 out of 13. Now, what's the probability of getting an odd number card? And for this, it's important to know if jacks, kings, queens are counted as numbers, and in this example, they're not. So we have 1, a 3, 5, 7, and 9 are odd cards that are available to us, and we have that in the hearts and in the diamonds. So 1, 2, 3, 4, 5 in each gives us 10 over 26. Now, what do you think the odds are of getting a spade given that a red card is chosen? Well, here we can see that there are exactly 0 spades out of 26 red cards, so the probability is 0. Sometimes it happens when we put a condition in, the probability is going to be 0 because it's just not possible. Now let's have a look at the rest of here. We've got how many even numbers. Again, face cards aren't counted in even or odd, so we have 2, 4, 6, and 8 and 10 are evens. So again, that's 5 of each, or 10 out of 26, and that reduces down to 5 over 13. Now 5 or less and less than 5. This is an important distinction. 5 or less means we include 5. So it's going to be 5, 4, 3, 2, 1. That's going to be in our set. And we're going to have that for the aces, or sorry, for the hearts and for the diamonds. So 1, 2, 3, 4, 5. Again, this is going to be 10 over 26 or 5 over 13. Now less than 5 does change things, and this is important to know which way we're going, because less than 5 does not include 5. It means it's only 1, 2, 3, and 4. 5 is not included in there. So we have 1, 2, 3, 4 in hearts and in diamonds, giving us a total of 8 over 26, or 4 out of 13. We're going to practice a few more conditional probabilities using cards. Just remember that the given is how we limit the condition, how we limit the cards, which ones we pull out, or how we limit that pool. For this next exercise, we're going to limit the cards in a different way. We're going to say that the given event is that a face card is chosen. So visually, this is what our pool is going to look like. Now things are getting a little different. Right now it's written out in sentences, so let's read through and see if we can figure out how this would look. So the probability of getting a queen given a face card is chosen. So that would be something like the probability of Q given FC for face card. So what is the probability that we draw a queen given that a face card has already been chosen? Well, we have a pool of 12 to draw from, and we have 4 queens from that 12. So our probability, if we reduce the fraction, is 1 over 3, or 0.33 repeating. So next, what's the probability of drawing a red card given a face card is drawn? So it might look like something probability of R given face card. Now let's look at our pool. We have 12 face cards and 6 are red. So we have 6 out of 12, or 1/2, or 0.5. What's the probability next of getting a jack or a king given drawing from face cards? So for this, we have an or, which means we take all of the jacks and all of the kings, and this is a little weird because it's either or. So a jack or a king gives us a total of 8 possibilities out of our 12. So the probability of jack or king given a face card. And sometimes these conditional probabilities happen. And that gives us an 8 out of 12, or 2 out of 3, or 0.667 repeating. So for this next exercise with conditional probability, we're going to do kind of a double whammy for conditional. First, we've shrunk down our pool, and it's cards 10 or less. We're going to be given a list of events and then some notation that can be a little tricky. So we're given this list of events, A, B, C, and D. So let's read through those really quickly and kind of figure out what those are. So event A is getting a card greater than 8. So for A, that's going to be 9 and 10, because greater than 8 doesn't include that. So for event A, we have 8 out of 40 cards, right? So let's 8 out of 40 here. Now event B, getting a card less than 7. Which numbers are going to be included in this? A card less than 7 is going to be 1, 2, 3, 4, 5, and 6. But not 7, so just less than 7. So that gives us 1, 2, 3, 4, 5, 6 options, and repeated in each set, so 24 out of 40. That's our odds for event B. Now let's look at getting a red card. Okay, well this one's pretty easy, right? This is just a half of it, so we have 1/2. We have 20 out of 40 red cards. The same with the black. It's 20 out of 40, or 1 out of 2. Now let's look at getting a card less than 5. And that's going to encompass 1, 2, 3, 4, but not 5, meaning that repeated in each of the sets, we're going to have 4, 8, 12, 16 out of 40 for our probability there. And oftentimes in questions you get options that look like this, right? And it can get a little overwhelming at first. My tip is to look at the given event first and how that shrinks down the pool. So let's go through these a little bit. So probability of event A given C. So the given event is that we get a red card. All right, so I know that my denominator or my pool that I'm choosing from is out of 20. Event A is getting a card greater than 8. So I know that that's 9 and 10. So 9 and 10 in hearts and diamonds is 4 out of 20. Now let's look at probability of A given E. So the probability of A given E, the given is getting a card less than 5. Okay, so I know that I'm looking at 1, 2, 3, 4. Perfect. So event A is getting a card greater than 8. Well, that's not something that can happen. So our probability is 0. Because 0 out of our cards less than 5 are also greater than 8. Probability of B given D. So again, look at the given condition and shrink your pool down that way first. So the condition is D getting a black card. Okay, that's again 20. So we're good. We know that there are 20 black cards to choose from. And getting a card less than 7 is event B. So B given D. So card less than 7, we have 1, 2, 3, 4, 5, 6. And that means that ace through 6 of the black cards, or 12 out of 20, is our probability of B given D. Now our probability of B given C, so our C is getting a red card, and it's the same probability B, and we're going to have the same numerator and same denominator, so 12 out of 20. So our next problem is, what's the probability of B given A? So A, the given condition, is getting a card greater than 8. So I know that I'm choosing from the 9s and 10s of all of the sets. Now the probability of B is getting a card less than 7. If I only have 9s and 10s to choose from, there's no way I can pull out a 7. So that probability is 0. The probability of D given E, all right, so E we know it is getting a card less than 5. So I know it's 1, 2, 3, and 4 of all of my cards so far, and then D is getting a black card. So I look at 1, 2, 3, 4 in my cards, and how many are black cards, right? So it's 1, 2, 3, 4. 1, 2, 3, 4. So it's going to be a total of 8 out of 16. So sometimes we get this notation where it's P given B, or P probability B given C, and then we're given a list of events. And it's often helpful to look at the condition and then look at what meets that criteria after that. So this is just a quick reminder that we've been dealing with a mathematical formula. And as long as we follow the rules, if we have two pieces of information, we can find the third, whichever one it is. So sometimes we're given different probabilities and we're told to solve for another. So let's see how this works. With the probability of B given A equals the probability of A and B divided by the probability of A, right? Now let's say that the question wanted us to solve for the probability of A and B. We have the other pieces of information, and so we can do that. So we multiply each side by the probability of A, and we get that the probability of A and B together is by multiplying the probability of A times our conditional probability of B given A. Similarly, if we're asked to find the probability of A, if that's our question mark, right? And we have the other two pieces of information, we can solve for that. So we'll take probability of B given A equals probability of A and B together, all divided by our question mark that we're looking for. Now for this, we have two equivalent fractions, and we can use the bow tie method and solve for it. So we would get that our question mark times probability of B given A equals the probability of A and B. And remember, we're just moving things around following the rules. If we divide both sides by the probability, the conditional probability, we can solve for the probability of A. And this is a helpful tip to keep in mind. We'll do one example really quickly. So let's say our question asks us to solve for the probability of A and B, or A and C. Let's do that, A and C, right? And that's what we don't know, that's our unknown. But we're given that the probability of of A given C is 1 over 5. We found that earlier, right? And we're given that the probability of C is 1/2. We can set this up to solve for the probability of A and C together. So we'll put our pieces. Our conditional is 1 out of 5. Our probability of A given C equals, I'm going to put a question mark for what we want for the probability of A and B. And we're given that the probability of C is 1 over 2. Now we're dividing by a fraction, which means we can multiply it by the reciprocal. So we flip it and multiply it by 2 over 1. That becomes 1. And we multiply this side by 2 over 1. That means that we've been able to find out that the probability of A and B together is 2 over 5. So just to wrap up this video, a quick review that with conditional probabilities, it's often helpful to think first of how your options are limited, and then to look at how many of those left over fit the event criteria. And remember that this is a mathematical formula, and when we follow the rules, we can find other pieces of information. As long as there's only one that we're looking for and we have all of the rest, we're good to go. Have fun. Let us know if this helped.